Where are LEDs made? The semiconductor chips in LEDs are made in the US, and most LEDs are assembled in the US. The top LED company globally is Cree. The revenue is $1,473 million, followed by Nichia and Toyota Gosei in Japan. All three have a focus on sustainability and the environment through several ways, such as revealing their greenhouse gas emissions, water and energy consumption, waste production, community involvement for sustainability initiatives, and offering education in regard to LEDs. How are LEDs made? LED stands for light emitting diode. Within the LED, there are a bunch of small diodes. A diode is a two-terminal electrical component that conducts current into mainly one direction. The diodes are made of a semiconductor material with two layers. The semiconductor material is a crystalline material with impurities added later on. One layer has lots of electrons and the other has few to no electrons, and the movement of electrons between the layers creates the light through electron excitation. Wires are then attached to the LED to power it, and the LED is encased in transparent plastic for durability and longevity. The process of making the LEDs vary depending on the size of the LED, but for a small LED, it can be completed within a few minutes. There are various chemicals used in LEDs. Common semiconductors used in LED manufacture are gallium arsenide, gallium phosphide, and gallium arsenide phosphide. Through a process called doping, impurities are added to the semiconductor to make the LED function correctly, such as zinc and nitrogen, and later on people are starting to use silicon, germanium, and tellurium. The wires connected to the LEDs are made of a gold and silver compound to form a chemical bond with the gallium in the semiconductor.
Each year, 20 million LED lights are sold and 500 million are in use today. In our project, we will be focusing on the white integrated LED flat panel Schafer light fixtures at 4,700 lumens. Niblock manufactures these lights and they sell them through home improvement retailers. Maddy has been a top LED lighting brand and trusted industry leader for more than 50 years. Home improvement retailers such as the Home Depot, Lowe's, as well as Amazon are the biggest retailers of this product and they sell them directly to customers. These lights are made for commercial, retail, office, and residential applications. These lights are also pretty large, so people tend to buy them if they are looking to light up a bigger space, such as a classroom, a warehouse, or an office. The packaging for these lights contain cardboard and plastic, but instead of using plastic, the manufacturing company could use biodegradable plastic. The best biodegradable packing materials on the market are made from starch-based plastics. These materials use plant starches to make a thermoplastic. Additives are used to increasing the heat resistance of the material. Plant starch-based materials also absorb humidity, which is a bonus in packaging. This is just an example of what biodegradable plastic looks like.
Ceiling lights are used to light up the classroom to allow for proper physics learning and create an effective teaching environment. Ceiling lights are used for a lot of things due to the fact they are in operation whenever the classroom is in use. These ceiling lights help us to discover much of our physics knowledge through allowing students to view paper, teaching faculty, and experiments. This would be very difficult without the ceiling lights. Lights are widely used across many disciplines and capacities. To put it into perspective, 15% of global electricity is used by lighting. Also, lighting is responsible for 5% of greenhouse gas emissions of the world. Although LED light bulbs cannot be reused to accomplish the same function, they can be recycled. This will be discussed later in the presentation. Calculations were done to determine how many hours per week on average the lights in E5 Holmes Hall were used. We took into account the 120-minute instructional team meeting, as well as all of the courses that are held in this classroom. We also took into account 20 minutes of light usage before and 20 minutes of light usage after each time the classroom was used. For LB 274, 001, and 004, this class meets 3 times a week, so 40 was multiplied by 3. For LB 274, 002, and 003, this class meets 2 times a week, so 40 was multiplied by 2. Once all of these values were added together, it was determined that on average the lights are in use for 1,900 minutes or 31.67 hours per week.
Based on the value of 31.67 hours calculated on the last slide, we were able to estimate the money that Holmes Hall saves by having LEDs in the physics studio. The average electricity rate of 13 cents per kilowatt hour was found using an online source. The energy that each light required was found on respective websites detailing specific wattage of each Schafer. Then, The cost was solved using these values along with the 31.67 hours that the physics studio lights are on per week, and values of 53 cents and 17 cents per unit per week were found for the fluorescent and LED troffer respectively. Assuming that there were about 10 units in the classroom, we found that fluorescent lighting was about $3.60 less per week. So, although the LED fixture might be more of an investment in the beginning, it seems to be worth buying in the long run. So where are these lights used? The white integrated LED flat panel troffer light fixtures are not only in the physics studio. Many of these lights can also be seen in supermarkets, hotel lobbies, restaurants, hospitals, and retail stores. So what is the purpose of having these fixtures? LED fixtures can last for a much longer time than incandescent or fluorescent light bulbs. In 2018, it was found that LED and fluorescent troffer units were priced similarly, but LED troffers saved on total energy costs. LED troffer lights usually last 50,000 to 100,000 hours. These LED troffer lights are able to give off bright and even light by being dispersed in a grid-like pattern on the ceiling.
Most LED light bulbs end up in landfills where they'll essentially sit for centuries and never biodegrade. Since LEDs do not contain any harmful chemicals, though, they are considered safe to throw away. However, a more eco-friendly alternative is to recycle them. LED lights can be recycled at most recycling plants and waste management companies for a small fee. Well-known stores such as Home Depot allow you to bring in your used LED light bulbs and Christmas lights, and they will recycle them. Recycling sites online such as Holiday LEDs allow you to ship in your LED light bulbs and they will dispose of them for you. Over 95% of LED light bulbs are recyclable. The recycling process of an LED light bulb consists of crushing the light bulb and separating the glass, aluminum, and other components of the light bulb. The glass and aluminum can then be used for other products. Although we're not able to gather information on what the LBC faculty does with lighting fixtures after use, we strongly recommend that they recycle them. We presume that not a lot of waste is generated from the classroom from using these LEDs because they are so efficient and can last for over 25 years. The United States Environmental Protection Agency presumes that one glass bottle takes approximately 1 million years to decompose in a landfill. Now, comparing this amount of glass used in one lighting fixture to a glass bottle, we say it's safe to presume that it will take over 1 million years to decompose.
In addition to the decomposition time, LED panels can be categorized as hazardous due to excessive levels of lead leachability and the high contents of copper, which are 8 times and 12 times their regulatory limit, respectively. And this is a problem because once lead enters the environment, it does not break down, and it often adheres to soil particles, and this lead can often enter groundwater, and all of this contamination could potentially cause lead poisoning for a variety of organisms. Lastly, due to the present situation, we're not 100% sure whether the lights in the room are fluorescent lamps or LED panels. So I did a little bit of research on fluorescent lamps and found that mercury is an essential part of them, as the electric current ends up passing through the electrodes, exciting the mercury vapor in the tube, as well as being an essential role in bulb efficiency. Once mercury is released into the environment, it could accumulate in water, water-laid sediments, and can convert into toxic methylmercury, which can act as a neurotoxin throughout the food chain.